What's up guys, it's Joe Hacks, and today we're going to be doing another top 10 vulnerability, and today we're going to be doing RCE. So basically, first of all, we'll start off by doing what is RCE. So RCE is basically known as remote code execution, and remote code execution means basically we are going to basically we can remotely execute commands on someone else's computer. So we might access like a website which is in say in USA, and we're from Europe, and we can remotely access their computer and do any commands. This works for like basically anything. Basically, it doesn't really matter if you're in the same region, same country. Basically, just anything in a different computer. So basically, this is basically we can execute commands remotely, and we can basically execute commands remotely on someone else's computer and stuff like that. So we can basically do some like ls who am I and stuff like that, and maybe we could try to get like a reverse shell. So like that, this is a very top tier vulnerability because it uh um basically very sensitive, and basically like if you do RCE and you get a hang of RCE on someone's computer, uh you can hack them, and for websites this would be a very top tier vulnerability they have to look into. So now let's start with the demo. So if you want to do the demo with me, just go to application.security, and here we see basically an application training a website. So here just hover over the play demo and click on OWASP top 10 for web. So basically RCE is it's a basically web application exploit, and here you see loads of these. Here you can practice these if you want. We did directory transversal the other episode. Basically this is LFI. If you can go check it out, it's the same playlist, and hopefully I'm going to be doing this playlist more. But today we're going to be looking at command injection. So just click on that, and here we can just read through this. The application. PayHub is an online money transfer service offering peer-to-peer transaction solutions, including online payments, currency transfers, and currency risk hedging. So we can just press next. Second, penetration test. Alice, the CTO of PayHub, has engaged a cybersecurity consultant, Bob, to perform regular penetration tests against PayHub's platform. And this just, you can read this if you don't know what penetration testing is. So first, he will start out with two-factor authentication. As an additional security measure, PayHub's development team has recently added two-factor authentication to the application login processes. For existing users, the feature can be activated by accessing settings menu and clicking enable SMS button. So we can just click the enable SMS authentication. And here we can say for configure, Bob decides to configure PayHub's two-factor authentication for his account by submitting his phone number below. So this is his phone number. Obviously this is a fake phone number, but yeah. And it's going to, if we click this, it is supposed to send an authentication code. So as Bob go ahead and enroll for two-factor authentication by entering your phone number above. Complete the action by clicking the send authentication button. So we just click this, and looks like we intercept the request. So if I intercept the request to understand how the two-factor authentication activation form communicates with the backend server, Bob intercepts the HTTP request generated by his browser using an application web proxy. So note just what is a web proxy. I'll just briefly go through over this because most people won't know what that is. So a web proxy is also known as a HTTP proxy. It's a software debugging tool that enables web developers to view, modify raw HTTP and HTTPS traffic between their machine and remote web application. This may include HTTP, HTTPS, request and response data, request variables and parameters, headers, and etc. So basically, it's basically intercepting the request. So I click a button and it's going to intercept. So basically, where it's going, what's its cookies and the connection and like where it's going and the variables. So we can just analyze the request, and upon clicking the send authentication button, Bob's browser generated a post request passing a phone as a parameter with his phone number, this as its parameter value. And we can just see here, we can just press next, and Bob is trying and reviews the code. So before we continue testing the application, let's further analyze how Bob's HTTP post request is handled by PayHub application to enable two-factor authentication. So the handle two-factor authentication method is used for generating two-factor authentication tokens and relies on third-party API service to generate SMS tokens for new users. To generate an SMS token for a user, the request.get parameter here method is called to extract the phone number parameter phone from the request body and assign it to the phone number variable. Basically, it's going to variable here, and we're going to get the this parameter, and we're going to assign it to the string phone number. The Java language runtime execution method is called to invoke curl, a command line tool for generating HTTP requests. The curl command expression is configured to send a post request to the third-party API endpoint API rule, passing the phone number variable as a secure string argument. Finally, upon execution of the curl command, the returned HTTP status responses are extracted via the HTTP code variable and returned as a JSON response to the browser. We can just press next here. So to modify the request, having analyzed the post request, Bob attempts to modify the phone parameter by appending his phone number with a semicolon and followed by the string XXX. We can paste this and we can hit forward. So basically the curl request is going to be this here. Detecting command injections. Interesting. Reviewing Bob's HTTP proxy response, we can see that JSON object returns a command not found error, which is usually caused when the bash shell program is unable to find the command. So understand the error. Let's look at curl's command execution on the server side. So analyze the code, and we see that the following to the modification of Bob's phone number, the curl string this semicolon XXS is appended to the curl string, which is executed by the exec method. And I'll show you this. However, since the semicolon character is interpreted as a command separator symbol, Bob's phone number string is interpreted by an execution method as two separate commands. You can find this in Bash, because let me just switch to my VirtualBox real quick. Say if we just open up a terminal and say we want to just cd into a folder I made for tryhackme, and we're going to do semicolon ls. So we cd'd into tryhackme, this folder, and then we did the semicolon and we ls. So it's going to first execute cd tryhackme, and it's going to list the following directories in the tryhackme folder. So this is how it works, and this is how most RCE exploitations are done. I just really wanted quickly to show you that to you guys, because most people might think that's wrong. Let's just come back to here. However, since I'm pretty sure we read this part, the first command executed by the exec method. So exec method is basically executing is this just basically our normal SMS gateway trying to send us the SMS. But the second command executed by the exec method is xxx. However, since xxx is not valid command on the Unix operating system, the backend operating system raises the bash command not found error, and which is returned in a JSON query. This is the ability to execute operating system commands by injecting shell meta characters. These are shell meta characters into an application runtime environment. It is known as a command injection or shell injection vulnerability. This is a very high vulnerability. RC is very high, and it's pretty quite easy to do too. But the level of severity it has on applications are is very high. So basically, now we can just copy the phone number, and we can do a semicolon, and we can do cat Etsy password. So initially, this should cat the Etsy password file, and which is the basically the system's file of storing their passwords and all the users. So this is very good for us to know if it's working or not, because it's also good understand. Basically, we're getting something in it, and we just forward request, and we can see that we got the the cat Etsy file for us. So basically tells us that root is a user in this, and there's loads of users in this. And basically the vulnerable code, to further understand the root cause of the command injection vulnerability, let's take a look at the handle two-factor authentication method for us generating SMS codes. So to recap, the handle two-factor authentication method is used for generating two-factor authentication codes. The phone parameter is extracted from the post request and assigned to the phone number variable. The phone number variable is then used for building the command string without any further processing. So it's not checking anything if it's malicious. And however, since the phone number variable is not validated before being passed to exec method, an attacker can insert arbitrary shell meta characters and command strings into the phone number variable, leading into arbitrary OS commands being executed on the application side. Basically saying that because it's not getting validated before it's getting passed to the exec method, the execution method, any attacker like us, we can just pass any arbitrary shell meta characters, so basically like semicolon, stuff like that, and we can do any malicious commands for us to get any like high sensitive information or getting a reversal from back to the application server. So we'll have a full hold of the application server. We can just click next, and here the mitigation, some of the mitigation rules. So to effectively mitigate against command injection attacks, developers must avoid passing user controllable input. So basically, developers must like stop giving user input that much. Like the developers shouldn't like really give the user to input something in functions or system calls that interfere with the operating system environment. Yep. So basically, we shouldn't give the users like input for something which might interfere with the operating system environment or the invoke third-party applications. If this is unavoidable, development teams must perform rigorous input validation against all user supplied data, which includes validation against allow list or permitted values, validation of the input length, validation of the input contains only alphanumerical values, ignoring all of the escape characters or whitelisting some strings. Also, they can do maybe always keep your operating system and third-party software up to date. So basically, if there is any RCE attacks, maybe it would happen to you if you keep them up to date. And maybe use buffer overflow protection, because you can also do buffer overflow through RCE. Maybe we might not be able to execute commands, but we can do buffer overflow so we can do some buffer overflow protections. We can sanitize the user input just like this was saying. Basically see if it's basically see if there's anything malicious. Maybe properly configure your user authentication mechanism. So basically maybe not give the user that much access, and maybe use a firewall, and have maybe use a proper threat or detection software, maybe to see if like someone is doing RCE. Please try to stop this. And if you do implement that, maybe have a response plan. So if someone does perform an RCE, maybe have a response plan on how we can like stop it and stuff like that. So now this is the fixed code. So this is a good code, like how it's I'm pretty sure they did some validation and stuff. In this fixed code example, we perform input validation against the phone number variable before passing it to the exec method. So basically it's going to validate the input before it's getting passed into the phone number variable, and after that getting passed into the exec method. So we specify the expected phone number format as a regular expression phone reject. So they created a phone rejects on how it should be. The phone number is number valid. The is its phone number valid method checks whether the phone number string matches that regular expression. So it's seeing if it will match the phone rejects. And if it does not, for example, because it contains additional characters and response without executing any command, thereby protecting the code against command ejection attacks, we will just basically say submitted phone number is not valid, and that's it. So I hope you guys learned something, and I'll keep you up to date on the top 10 OWASP web, and see you guys next time. Peace.